All right, guys, the last couple days we've been together, we've been talking about solving systems of equations by graphing, all right? So it kind of gives you an idea of what systems of equations actually mean, okay? However, what we're going to do is I'm going to show you a different way to do it. I'm going to show you without the graphing part. I'm going to show you how to take the actual equations and solve them algebraically. So that's what our lesson's called today. Solve systems of equations algebraically. Vocab, most of you guys are ready. Green on the left, notes on the right. Okay, we have one word today, and that word is called substitution, everyone. Substitution. So, it says, use algebraic methods to find an exact solution of a system of equations. Okay, so it's just the method that we're going to use today. All right, and I'll show you what that means. All right, so actually this hopefully will give you a rough idea. If you don't understand this, it's not a big deal, but this is kind of what we're going to be doing in the lesson. So if you have two equations, so y is equal to negative 5x and y plus x is equal to 8. There's your two equations. Instead of graphing them, here's what you can do. Because y is equal to negative 5x, you could take this and plug in negative 5x where the y is. That way you have the same variable. And then you can start solving that. And that, of course, is just the beginning. That's the substitution part. I'll show you how we're going to take that and wrap it all into one to be able to solve these. Alright, so if you haven't done so already, go ahead and grab your book, grab a piece of paper. Alright, put your name on your paper, assignment number, the actual assignment, lesson number, all that good stuff. And flip your book to page 427. Okay, so on the very first one, here's what I want you to do. I want you to put down your pencil and I want you to watch. Right? This is one of those that I'm going to do on my own. I just want you to watch and just see the basics, what it's involved here. So here we go. I have two equations. I have y is equal to x plus 8. And I have y is equal to 2. Okay? So here's what I'm going to do. Very first thing I'm going to do is I actually notice that I already have in both of them, the y is actually isolated, but this one tells me it's very simplified. It just tells me exactly the integer that y is. So what I'm going to do is I'm going to turn around and I'm going to take this and I'm going to plug it into the other equation. So instead of y, I'm going to plug in 2. So instead of y, I'm going to plug in 2. So instead of y equals x plus 8, it's 2 equals x plus 8. Now once I plug that in, now that's a one-step equation. I'm going to solve it. So in this case, subtract 8 from both sides. And I have these cancel, right? I end up with x is equal to, and then 2 minus 8 is negative 6. Now if I wanted to, I could then take this, I know what x is, I could then take it and plug it in here. Negative 6 plus 8 is positive 2, but we actually already know what y is. And ladies and gentlemen, because of that, I have my system of equations. When x is negative 6, y is 2. And that would be our final answer. Okay? Now, let me warn you that is pretty simplified. All right, but I wanted to do a simple one for you just to get an idea what the substitution method is and how we can use it algebraically to find out our system of equations. Okay, now I do have to give you guys a heads up on this lesson. All right, in years past, the struggle that my students have had is the lack of organization. they get lost within their own work. Now I have to warn you, this is going to be a lot of work for each problem. If you notice up there, if you actually count them, it's only the first portion of our lesson. The rest are review. The first portion is our actual lesson. That's the practice. If you look at it and you think about it, it's not very many. Okay? So that's because they take a long time. All right? And there's a lot of work involved. So I'm going to walk you guys through this. Let's go ahead in our lesson and let's do problem number 4. Problem number 4. Okay, on problem number 4, our two equations are 3x plus 2y is equal to 30. And our second equation is x minus 2y equals negative 6. Okay, now here's what I do. Now you could do it a number of different ways. Okay? However, I'm going to try to give you guys some pointers on the steps on trying to make it. It's not always the easiest, but kind of strategy-wise, I'm going to try to make it easy on myself, or of course you guys making it easy on you when you do it. So here's what I'm going to do. Step 1 is I'm going to look at both of these, and I'm going to try to find the one that would be easy to isolate a variable. It could be x or y. It doesn't matter. Now, if I'm looking here, and I'm going to isolate y over here, I'd have to box in the 2y. I end up dealing with like a two-step equation. But if I look here, if I isolate that x, I just do one thing. Might as well make it easy on myself. There's no fractions involved, no nothing like that. So here's what I'm going to do. I'm going to find the easy one, and I'm going to isolate the one variable. So to be able to do that, I go ahead and of course, take my term and do the opposite, do the inverse. In this case, a negative 2y, I'm going to add 2y. Whatever I do on one side of the equal sign, I do on the other. So these cancel. I end up with x is equal to, and I have, of course, you don't have to put it in slope-intercept form. I'm going to go ahead. I'll just put the variable term up front. I didn't have to. I could put negative 6 plus 2y or positive 2y minus 6. Either way, I'll put it like that. Okay. So out of the two, find the one that's the easiest. Try to isolate the variable. Okay. And you could do it for x or y. It doesn't matter. So now I have what x is actually equal to in relation to y. Okay. So here's what I'm going to do now. Is I'm going to take this here and I'm going to plug this in to one of these equations over here. I'm going to plug 2y minus 6 in for x. So if I take a look here, I can plug it in here, or I can plug it in here. Well, if I plug it in here, that might be the easiest, because if I plug it in here, I'm going to have distributive property. I'm going to have to multiply all of it with 3. That doesn't matter which one I do. Again, try to keep it easy. Okay, it doesn't mean that in the end it will be the easiest, but I'm just kind of trying to think ahead. So I'm going to go ahead and take the x here, and I'm going to instead write 2y minus 6. 2y minus 6 in for x. Now we've done this year, and a lot of us just want to like shake our head every time I say, guys, use parentheses. But ladies and gentlemen, use parentheses. It's kind of what it's been preparing you for. So 2y minus 6, okay, and then I have my minus 2y equals negative 6. Okay, if I do this, take a look. There is nothing here. I could drop off parentheses. Does anyone see a problem here? Well, let's take a look. I'm going to combine like terms here. 2y. You add 6 to both sides. Okay, listen. When it comes here, when you plug it in, we just plugged it into the same equation we just solved, right? So when you plug it in for step 2, you need to plug it into the other equation to prevent you. So if you find yourself doing this, be careful. Okay? So I just solved one equation. I'm now going to plug it into the other equation. So in this case, keep that on your paper. That's extremely important. Okay? But X it out. Don't scribble it out. Just X it out. Okay? That reminds you of why you need to plug it into the other equation. So what I'm going to do is I'm going to go ahead, take this, plug it into the other equation. So yes, we do have to do distributive property. Now you're going to see why it's important to use parentheses. So instead of 3x, I'm going to plug in 3 times 2y minus 6. Okay, I'm looking here. Plus 2y equals 30. Okay, now I'll just write it here with our other notes. Plug in to the other equation and solve. So I need to do distributive property first. So 3 times 2y is 6y. 3 times a negative 6 is negative 18. Plus 2y is equal to 30. Now I go ahead, continue to solve. In this case, I can simplify or combine like terms with 6y and a positive 2y. That gives me 8y minus 18 equals 30. Now we have a basic two-step equation. Box in our variable term, add 18 here and 18 here. So we end up, when those cancel, 8y is equal to 48, which means that we divide both sides by 8, and y is equal to 6. Now, here's what I would recommend that you do. You don't have to do that. You can box it in with your pencil if you'd like. There's a lot of boxing and kind of organization going on. Once you find in a problem, you find out what your one variable is, or your one part of your ordered pair, I would highlight it, or I would do something with it to make sure it stands out. Now that we have y, on this one, step 3, remember our goal is to find x and y, because that's a whole part of systems of equations. Now on this one, I'm not fooling you guys, I could truly plug in 6 for y on either one of these. So this one is plug in the variable, okay, for any of them. So in this case, it doesn't really matter. I'll use the x minus 2y equals negative 6. So x minus 2 times 6 equals negative 6. I'm going to simplify this side and say that is x minus 12 equals negative 6. And of course, that is now a one-step equation. So add 12 to both sides, and I get x is equal to 6. Step 4, write your answer, ordered pair. When x is 6, y is 6. And there you go. So just a quick little review. The very first thing you do, take a look at your two equations. Choose one that is the easiest to isolate the variable. So what I did was I isolated the x. That told me what x was in terms of y. So then you take it and you have to take whatever that is, plug it into the other equation. So instead of 3x plus 2y, it was 3 times that plus 2y equals a 30. Solved it to get one of them. Then I take that, and now I can truly use for step 3 either one of those equations and plug that variable in, that number in for that variable, and get your second variable, and of course finish it off with step 4, write your ordered pair. Okay, questions?
For when you solve for y, can you plug in 6 right next to the x equals 2y minus 6?
Oh, yeah, because you think about it, right? Each of these equations are all equivalent to each other. I should say this and this is, because you just use that to simplify to that. So that would work too. Yep. All right. Any other questions? Okay, here's a problem I want you to try out. And I'll leave this up here. I want you to try out problem number 16. Number 16 on your homework. All right. I'll give you guys, I'm sure it'll probably take longer than 2 minutes, but I'll check in with you guys in 2 minutes. All right. Number 16. Go. Okay. How many of you need more time? All right. All right, checking in. How many of you still need more time? Okay. Okay, one last check-in. How many of you still need more time? Okay, about one, I'm going to give you guys one more minute. Okay. Go ahead, turn to your neighbor, and share your ordered pair. Go.
I didn't get my ordered pair yet.
If you're a person that was almost done, then you need to talk to your neighbor and have them help you find that ordered pair. All right, here we go. So I have a couple different options. I'm taking a look. I can isolate either y. That's probably my best bet. Probably the easiest. Doesn't matter which one. I'll just isolate this y here. That's our very first step. So if I take a look, that's a negative x. I'm going to go ahead and add x here and add the x over here. So those cancel. I end up with y is equal to, and then I just have x minus 4. X and then negative 4. Okay, so here we go. I'm going to then turn around. Remember, I cannot plug it in this one. I need to plug it back into the other one. That's the very first, or I should say the next step. So I go ahead and say 5x plus, and instead of y, I'm plugging in x minus 4 equals 8. Now what this does is I take a look. This is a positive, like having a positive 1 outside. Because of that, I could just drop the parentheses. So I have 5x plus x minus 4 equals 8. If I combine like terms here, 5x minus 1x is 6x minus 4 equals 8. I go ahead. It's like having a two-step equation. I'm going to add 4 to both sides. When those cancel, I end up with 6x equals 12. And that's a one-step equation. X is being multiplied with 6, so I'm going to divide by 6 here and here to get x is equal to 2. There's our first one. And now remember, I'm going to take that and I'm going to plug it in to any of these. All right. So it was just mentioned, when it was asked, well, can we just plug it into this one here? Absolutely. All right. That is the same equation as that, just written differently. So I'm going to go ahead and I can plug in my 2 here. So y is equal to negative 2 minus 4. That means that y is equal to, well, negative 2 minus 4 is negative 6. No, wait, that's wrong. What did I do? X is equal to positive 2. I solved it in my head a second ago, and then when I got negative 6, I was like, wait, that's not what I just got. Sorry. See, it's very easy to just make a simple mistake like that, right? So 2 minus 4, yeah, that's negative 2. And there we go. So our last step, right? Our ordered pair, remember the x goes first, so 2, comma, negative 2. And there's our answer. All right, move on to a different type. This is the basic, this is a majority of your type of problems right here. This is the basics, but any questions before we move on? All right, well, then let's do problem number 6 together. Number 6. So back on 427. So I have 3x, I'll do this in red, 3x plus y equals 10. Then our other equation is 3x equals negative 10 minus y. So here we go. I'm taking a look. What would it be easier to isolate? I'm thinking since this is already a positive y here, it's probably easiest to isolate that y. So I'm going to, where I don't confuse myself, I'm going to rewrite this here. 3x plus y equals 10. So I subtract 3x from both sides. So I get y is equal to negative 3x plus 10. All right. So here we go. Remember, I'm going to plug it into the other problem now. I'm sorry, the other equation. So I'm going to go ahead and say 3x is equal to negative 10 times, minus, and then instead of y, I put in parentheses that right there, negative 3x plus 10. That way, if you haven't noticed, the whole reason we're doing this is to give us one variable in the whole problem instead of 2. Now, before I even do anything, I'm going to get rid of the parentheses on this right side. This is a little more challenging. Okay, this is a negative up front here. That is like having a negative 1. So I need to use distributive property. And in this case, so negative 1 times negative 3x is positive 3x. Negative 1 times a positive 10 is a negative 10. So I'm going to go ahead and rewrite this whole thing. I have a negative 10 in front of the positive 3x equals 3x here. I'm going to go ahead, combine like terms, so negative 10 minus 10, what I end up with is 3x equals, and then 3x and a negative 20, right? Minus 20. And we have seen something like this before. If I bring my x over by subtracting 3x, this cancels. Over here, of course, we end up with 0 equals negative 20. Remember when on our lesson we had variables on both sides, when we end up with that, what's our answer, guys? no solution. Okay. When you come across one like this, just make sure that you didn't plug it into the wrong equation, right? So I simplified this equation here. So when I plugged it in, I plugged it in the correct equation. So it is no solution. Okay, I want to do one more with you guys, and then I'm going to let you try one. Let's take a look at problem number 13. Number 13. Number 13, I have 2x equals 7 halves plus a negative 3 halves y. My other equation is 4x plus 3y is equal to 7. All right, here's what I'm going to do. I'm kind of thinking ahead. And I'm going to try to divide both sides by 2 on this one. So I have 2x equals 7. Notice how so many of us are going to want to go, I'll just try to do it over here, and that's where we go wrong. Take the extra second, rewrite the problem, give yourself enough space to solve it. Okay? So what we have is I'm going to go ahead, isolate the variable. It's being multiplied by 2, so I'm going to divide by 2. Now, I can either divide by 2 and I can divide both of these by 2, both of these terms. Or, isn't that the same also as multiplying by its reciprocal, 1/2? If I do that, I would then multiply each term on the other side by 1/2. So these cancel. I end up with x equals 7/4. And then I have 1/2. That is, of course, a positive times a negative. So negative 3/4 y. Okay. Here we go. Be careful, I'm not plugging it back into this. I'm going to plug it into this one. So when I do that, I'm going to come over here. Instead of 4 times x, I'm going to put 4 times parentheses 7/4 minus 3/4 y. Then plus 3y equals 7, right? All I did was change the x to that. Now, distributive property. 4 times 7/4, guys, is what? 4/1. Don't the 4's cross cancel? I end up with... Okay, do we not see what I'm talking about? 4 times 1 times 7/4. The 4's cancel out. We end up with a nice clean 7. Same thing happens here. 4's cancel out. I end up with a negative 3y. Plus 3y equals 7. Okay, so if I combine like terms, actually what I could do is I could subtract 7 from this side and from this side. End up with negative 3y plus 3y equals 0. And ladies and gentlemen, combine like terms here, what do I end up with? Remember when the 2 numbers on each side are the same? What's our answer there? Well, what did the book call it? Infinitely many solutions. So you will, I just wanted to go over those with you because you'll come across both of those type of problems. Okay. Of course, it's also good to go this because of the fractions to go over that. Okay, questions on this? Ladies and gentlemen, I have not done one skill here other than the actual what we're talking about in this lesson. I haven't done one skill that I have not taught you already this year. It's just taken all the skills that we've talked about and kind of putting many of them anyway into one big math problem. Okay, we do have one more type. I'm only going to get you started on this one. All right, so let's go ahead and let's take a look at problem on page 427, problem number 7. 427, problem number 7. It is a word problem. Let's close read it really quickly. Lola paid $13 for 6 greeting cards. Some cost $2 each and some $3 each. Write and solve a system of equations to represent this situation. Interpret the solution. So, they have a word problem. They want us to come up with a system of equations. So, the information they give us will always give you 2 pieces of information, or 2 different types of pieces of information. So, watch this. The very first thing they're going to give us is they're going to talk about price. All right? So, for number 7, Lola paid $13 for 6 greeting cards. Some cost $2 each, right? So, here's what I'm going to do. If I bought 5 of those, right, wouldn't it be $2 times 5? In this case, it's 2 times x. We don't know how many $2 cards. But what we do know is if we add it with the $3 cards, which we don't know how many she bought there, so that's, and you can't use an x, it's a different kind of card. It's going to equal $13. Now, the other one is, the first is the price. The other one is the number of cards. Price and the number of cards. So, in this case, okay, we have so many $2 cards plus the number of $3 cards equal how many, guys? Equal 6 cards. Okay, I'm going to put a little star down here. Pay attention to what your variables are, ladies and gentlemen. Right here, this is the number of $2 cards. This is the number of $2 cards. This is the number of $3 cards, number of $3 cards. It will mean the same in both.